Okay, so this is the 2012 paper in your red book or hot pink book. The maths has been changed to suit first principles, so it's going to be different. So the first thing that we're going to do is we're going to fill out our table, knowing that on this side, this is whatever is going in the attic, and this side is whatever is going in our basement. So we scroll through, and the other thing that we know is that if something is in the attic, it is going to be not a whole number. So if I scroll, that is now 20.8. So that's not the whole number. That has to be in the attic. So I'm going to put the 20.8 here. Do I have a concentration for that 20.8 hydrochloric acid? No, I do not. And if I scroll through my question, it says down here I need to find the concentration of hydrochloric acid. So this is going to be a question mark. My ratio is going to be 2. If I look at the other side, then it must mean that the thing that is essentially 25.0 must be the volume that I pipetted. And we read. I have 0.05 molar is my concentration, and my ratio for my equation is 1. I'm looking at my question. There is no extra information. I've used this piece of information, this piece of information, this piece of information. I am good to go. Okay, so I am ignoring B at the moment, and I'm even ignoring C. And what I'm going to do is I am going to attack this as if I just need to find out big M and grams per litre, and I'm going to check back afterwards. So we have said, or at least I have said, this is your way in. The 0.005 is where you're going to start. So we have 0.05. We're going to divide it by 1,000. And when we do that, we're going to get minus 2, 3, 4, 5. 5 by 10 to the minus 5 moles in a centimetre cubed. Okay, I should have said up here that 0.05 big M is the same as saying 0.05 moles in 1,000 centimetres cubed. So apologies for that. Okay, I'm going to put my W up here. So again, just to show you what we're doing, 0.05. If I go down, I am dividing by 1,000. So I get this. And the next step is to go up, so I'm multiplying by my titer volume. And in this case, that is the 25 centimetres cubed. So I need to get a calculator so we can do that. Okay, so now I'm left with 1.25 by 10 to the minus 3 moles, and that is in 25 centimetres cubed, and I just put TV after it. So I multiply by my titer volume here. I use 1.25 by 10 to the minus 3. Here at this point, I use my ratio, and the ratio I'm interested in is 1:2. So if I have 1.25 by 10 to the minus 3, and I'm now going to have to double that, that is going to become 2.5 by 10 to the minus 3, and that is moles in 20.8 centimetres cubed. Okay, so here's where I use my ratio. This section here, I didn't make my W big enough, so I now have 2.5 by 10 to the minus 3 moles for this. So the next step that we do is we're now going down, and this is going to be divided by this titer volume. So I'm going to divide 2.5 by 10 to the minus 3, and I'm dividing that by 20.8 centimetres cubed. And when I do that, I get 1.20 by 10 to the minus 4 moles, and that is now in a centimetre cubed. So remember, when we're at the bottom of our W, we are in centimetre moles per centimetre cubed. When we're at the very top, we're at big M, moles per litre, and when we're on our flat bit, that is moles at our end point. Okay, our last little bit then is we have to multiply all of this by 1,000, okay, because we're going back up our W, so multiply by 1,000, and when I do that, it is going to come out as 0.12019, okay, big M. Now, you have to have your answer to the significant figures that are in your question. And in this question, in our table, 20.8 is 3 significant figures, 25.0 is 3 significant figures. So if I leave this like this, it will be marked as what's called a slip because I haven't given an accurate answer. So to make sure I don't lose marks, I go to 3 significant figures. So technically that's here, and I have a look at this. 1 doesn't round it up, it leaves it as it is. So I go 0.120 big M. The last thing we said we do is that we look at our mass triangle. So our mass triangle, we now have 0.120 big M. We're looking for the molar mass of our sodium carbonate, our hydrochloric acid. So again, you always show all your workings out. It's equal to 1, it's equal to 35.5. That is a total of 36.5. So for our last bit, I go 1.20 big M by 36.5, and that is going to be equal to 4.3870. So when we look at this, again, 3 significant figures. This is 3 significant figures. I have to have a look at the 7 here. That's going to bump this up. So 4.39 grams per litre. Now, we have said if you cannot annotate, so looking at C up here, there's an annotation of 1, of a 2, and of a 3. If you can't annotate, you just leave this as it is. I'm going to show you where your annotations come now. So the number of moles of sodium carbonate per 25 centimetres cubed, this is the answer to this. So technically we can add this in as a 1. Okay. Our next thing that we're looking at, the number of moles of hydrochloric acid that reacted. So this is when we used our ratio. We found how much of HCl we had. This becomes our 2. Our last one, then we're going to D. So obviously this is C, this is C. D asked me to find my concentration of HCl in moles per litre. This is D part 1 down here, 0.120 big M. And then in terms of grams per litre, don't know where that disappeared, but it did. It should be this 4.39 grams in a litre, and this is D part 2. Now, again, if you cannot annotate, then at the start of your question, the maths that you're doing is for C and D. That's how you would leave it. I'm going to go up to the top bit, and it says, calculate the exact mass of anhydrous sodium carbonate required to make 500 centimetres cubed of 0.05 M. So this is now, I think it was said it was B. So 0.05 moles, and it's 500 centimetres cubed. And we are doing sodium carbonate. So what is the first thing? I have a volume in here. This is not a gas, so my molar volume triangle is not going to work. PV is equal to nRT is not going to work. This is a liquid, so this is going to be our 4th triangle. So my 4th triangle is always a big M. It is V over 1,000, and that's going to give me my moles in here when I'm done. So there's going to be a 2-step process to this. So from my question, my big M now becomes 0.05. I'm going to multiply that by 500 over 1,000, like so. So we go 0.05 multiplied by 500 divided by 1,000. And when I'm done with that, the moles that I get are 0.025 moles. The question asked me to find the mass. So that must mean that I need to go into my mass triangle. So we are filling in what we know, 0.025 moles. This is my question mark, which means I need to calculate my side bit here. So I have Na2CO3, which will become 23 by 2, which becomes 12, which becomes 16 by 3. I add this all up, I get 106. So I'm going to multiply my 0.025 grams by 106. And when I have done that, I get 2.65 grams. 2.65 grams. So this then becomes, the answer to 1B. Okay, if you need to annotate.